In this question, we're asked to explain why on a curved path at constant speed, it's accelerating. Well, we'll start with our premise, and then our observation, and then our conclusion. So the premise certainly starts out as acceleration is the rate of change in velocity. Velocity is a vector quantity that has magnitude, which is the speed, and direction. A change in either is a change in velocity. With speed constant, the direction changes continuously as the car goes around the curve. A change in direction is a change in velocity. And if there's a change in velocity, there is non-zero acceleration. Very important about centripetal acceleration and centripetal forces. In the next instance, we have a marble that starts up at A. It rolls down the track. The track has been bent. It goes around this circle. We're told the point A is 0.8 meters. B is the lowest point, and C is the highest point on the loop, which is 35 centimeters. We have the mass. There's frictional forces can be ignored, and kinetic energy due to rotation of the marble can be ignored. And use 10 for G. At point C, draw an arrow to indicate the direction of the resultant force. Well, this thing is traveling in a circle, so the resultant force is toward the center. FC. I'll just put it that way. Let's call it the F net. State the names of the two forces acting on the marble. Well, at that point in time, we have gravity pulling it downward. And we have the normal force represented by the track. The normal force. The ball is pushing against the track, and that's why it's changing direction. So the ball is trying to move straight, and the track is in the way. So the track exerts a normal force on the marble. Deduce that the speed of the marble is 0.3 meters per second. Well, whenever we have changes of speed and changes of height, we should be thinking about conservation of energy. So we have some potential energy up here, and we have a different level of potential energy here, and a different level of potential energy here. So this, the total energy we have at the top, and this is the potential energy equal to 0 at the bottom. And let's say this is the potential energy at C. Well, the potential energy at C, what has happened to the potential energy from A to C, all the energy, the potential energy that's lost has been converted to kinetic energy. So this here represents the change in kinetic energy as well, which is 1/2 mv squared. And the gravitational potential max is mgh, as is C, mgh. So at this time, we have a total conservation of energy. So we have a total energy, which is equal to the initial energy of the system. The total energy is going to be EPG max. And afterward, we have an exchange between gravitational potential energy and kinetic energy. And this is mgh, h0 for the beginning. This is mgh later, and this is 1/2 mv squared. Now we notice there's an m in every one of these three terms. And in every case, it's talking about the mass of the marble. The mass of the marble's potential energy, the marble's potential energy, the marble's kinetic energy. So for that reason, these m's can drop out. So it's interesting then, the answer to this question does not depend on the mass. And we're trying to find the velocity. So we will do some subtraction, some algebra here. We have gh0 minus gh equals 1/2 mv squared. And we'll just bring that up over here. gh0 minus gh equals 1/2 mv squared. So twice gho minus gh equals mv squared. V squared then is 2 over gho minus gh all over m. And the velocity then is the square root of that whole mess, which is 2g. We'll factor out a g. Square root of 2g ho minus h all over m. So that's 2 times 10 times 0.8 minus 0.35 all over, oops, the mass had dropped out. Sorry, that mass is not there. So 2 times 10, or 20, square root of 20 times 0.45. That's the square root of 9, which is 3.0 meters per second. And you notice that is the answer we're given. Lastly, we're asked to determine the resultant force on the marble and the reaction force on the track of the marble. And we're going to do that in the second video on this question.